Okay, the live has started. So I'll just. Okay, we can start now. Good evening, all. Thank you all for joining us. So first of all, let me just give a brief introduction about Robovice. So Robovice is a robotics organization we started last year, and our aim is to help students master their skills in the field of robotics engineering. And today, you all have joined our first on our series of Virtual Robotics Show, ViceView. And for our first session, we have collaborated with Orangewood Labs, and we have Sankarshan Bangaloree, who is the senior robotics engineer, and he's working with Orangewood Labs. So he'll be introducing further about Orangewood Labs and also about their product, Owlboard. So once again, thank you so much, everyone, for joining. So over to you, Shanky. You could start with the session.
Great. Thank you so much for introducing. Thank you so much for Robovice and ViceView for hosting this show for all the robotics enthusiasts. My name is Sankarshan Bangaloree. I'm also known as Shanky or Shanky Robot, basically, because I work quite a lot with robotics. Orangewood basically is a company that is making affordable collaborative robot, and our tagline is democratizing robotics with collaborative robots. So what democratizing is like, we are not making robots or robotic systems be only used by industries. You can use collaborative robots or robotic systems for any application that you want. You have seen several robots that's there in the world. You might have seen some robots that can walk, that can talk, that can run, that can do heavy lifting, assembly, manufacturing as well. What we are building in Orangewood Labs is we are building collaborative robots, which are smaller scale robotics. It's collaborative because it collaborates with human beings. It all started a few years ago when the founders basically founded Orangewood Labs as a furniture-based company. So it started where they were building furnitures because of the name Orangewood itself. So it's a wood type of wood. So it started with like the wood industry. And then when they were working, figuring it out, it's a Y Combinator company in US. There are quite a lot of problems finding painters to paint their furnitures. So furniture needs to be polished, paint, varnished, everything. And the reason they could not find painters to do that work is because all the paints that they use is toxic. So people don't tend to work in such hazardous conditions of such hazardous, using hazardous chemicals like that. And then they found out robots do this work pretty well and for pretty cheap in a way. So they got some robots, started making the robot do the painting work, so which took over the hazardous aspect, and people did not face some problems with the health conditions due to the chemicals that is used in painting. So once they started seeing that robot are so useful, they switched from building furniture to robotic company itself. So that is where the whole transition from furniture to the robotic systems happened. Here are my colleagues who are working. So that's Ramdas, who will be the behind the scenes guy for this presentation and demonstration. And these are the team that are working with AGV robots. So if you see, this is the robot that's there. And we have another robot that I'll be demonstrating later down. So if you see, this is the robot that we have put it just the camera. So yeah, this is the robot that is in the spotlight. Yeah. So that is in the spotlight.
Is it possible to increase the volume?
Yeah, sure.
It's a bit low as of now. It'd be great if it's a little more louder.
Is it better?
It's still a bit low. If it's possible, otherwise it's
okay. Is it better now?
Yeah, it is better.
Yeah. The spotlight. I think there's a feedback that's happening. So yeah, this is the robot that I'll be demonstrating later down while showing what's happening. So they are working on this robot right here. Let me show you some videos to understand what collaborative robot is, what robotics or how Orangewood robotics is doing. Let me share you the screen. So we have here first I'll show you how it get us know better. So we are a robotics company that builds collaborative robots, also in short known as cobots. So these are the smaller robots that can do repetitive mundane tasks like picking place from here and here, doing welding, doing spray painting, doing powder coating, doing sanding work. A lot of applications that people would do day in and day out and get bored. So we are taking over the jobs that are pretty boring, and we are also in taking robotic systems in such a way that it's collaborative in nature. It's not like okay, robot is taking your job in this case. It's like robot is helping you with your job. So if your work has something that you need to do repetitively, this will take care of it. So that is what full collaborative word comes into picture. Sometimes these robots are collaborative in such a way that okay, you have fingers and your fingers are dexterous. You can do a lot of things with your fingers. But robot, in the sense, don't have that much fingers. So you can add attachments over top of it to a particular application. So you can pick something here, place something there. You can put a welding gun in front of it, weld something. You can put a screwdriver or drill machine. You can drill holes or screws or nut and bolts. And if you put a painting brush, it will start painting. Or if you wanted to dance to music, it will also start dancing. So that's the whole idea and concept behind robotics. I have few example videos to show. And let me show you first with the coffee cup. So if you want your robot to, lift up a coffee cup and bring it to you like a barista and serve your coffee to you. So here you can see we have added attachment that will lift a coffee cup and will serve you the coffee cup. So you can have like a hot cup of coffee. The robot can also make the coffee. You can take it from a coffee machine and serve it to you. So this is like the whole general idea of different applications that the collaborative robot can do. And this is one video, and this is something called as hand training. Not all robotics needs to be like a completely code programming. You need to do C++ programming or Python programming, something like that. We are democratizing it in such a way that you can take the robot, put it into a hand teaching mode. So you basically take the robot, move it to different location, different place, and then press record. So you keep on recording the motion that the robot is doing, and once you press play, it will keep on repeating that motion. So you're not doing any program. You're pressing one button which says like okay, learn, and you're pressing another button that okay, once you're learned, now start doing the work. So this is what the robot is doing. So as you can see, this is another colleague, Anirudh, who is doing the hand teaching the operation for the robot, and the robot is doing that work repeatedly. So this is a whole general idea of teaching robots without doing programming, and we're moving towards no code program altogether. Okay, I'm sorry about the audio if it's not very loud. This is the max I can.
Yeah, it's actually not so audible. I think the thing is that it's fluctuating, so it's going high and low like that.
Okay. Probably change the setting of it.
Maybe you could connect a phone or something, and you can speak that way if possible.
Yeah, that's also fine. Yeah, that will be much better. Just give me a moment. Till that time, you can see robot pick and place, where the robot is picking things up using vacuum suction gripper. So the orange thing that you see here is using vacuum, and using vacuum, you can like pick something up, place something there. It's usually used for things that have flat surfaces. So if it's like weird structure like a rock, it won't be able to lift like that. So it needs like smooth, soft structure. So as you can see, it's like lifting different phones up, placing it in different way that you want it to run. So this is one of the very common example that's because think of in a situation where you're ordering things from Amazon, Flipkart, or some different companies, and you're trying to get all these packages put from one place to another place so that it just ships properly, or even the postal services or courier services. If a human being is told to just take the box from here, put the box there, all his life, it will be very, very tiring. It will be very, very boring. So this is what robotics helps with. Robotics takes that boring job and makes it easier for us so that we have work that uses our mind. So this is all about using our. Okay, I have connected to the audio. 1 second. So am I audible now?
Yes, you are. You connected
Okay.
to another device?
Yes, yes. I'm using my phone for this.
Uh-huh.
Great.
Good, keep it near.
So this is another example that I've shown. And now think, you have coffee cup that can be placed in hand of like it can be given in your hand. You have phones or some other particle that or something that can be lifted and placed into your hand, table, or someplace else. So the logistics is done. If you want the robotic arm, which is pretty much like your arm, to move around, you need it to have legs, right? It cannot walk around saying like, okay, now I have hands, automatically I'll have legs. It's not like human beings that so what we do is instead of giving it legs, we give it wheels. So here is another application of this robot where you can see the robotic arm that is mounted on top, and it's doing the task of spray painting. So this is just for demonstration sake, where the compressor is put in with the paint mixed in, and it has four-wheeled robot which is moving around painting the surface or the floor. This application was specifically done so that to build custom houses. So there's wooden boards on the floor, so it's like painting it in repetitive fashion. So it's going around doing the paint action again and again. And as I've said earlier, paints are very toxic, and not all paints are very, very safe for human beings. So this is where like it's like killing two birds in one stone, where the robot is doing the repetitive task, and also robot is doing something that's very hazardous that the human should not technically do. So this is the best example that I can show you. We are still working on the robot that's behind me. So if you see, the work is in progress. So that's the robot that you can see here with the case and everything closed up. So that is what the whole robotic system is all about. The cool thing about this is there are different tasks or applications that you can do. Now, instead of just handing over the coffee cup to you in your hand, it can go to a coffee shop, it can buy the cup of coffee, it can bring it to you, and it can serve you on your hand. Or probably you're sitting in an office, it will use the lift, it will climb up, and then it will go into your cabin, and you just keep it on your table or hand it to you directly. So this is what giving it legs basically means. We have another robot which I can demonstrate in the office. Before that, I'll show you a powder coating example as well. So there's a lot of examples with robots that you can do. And not all robots are similar, but here, this is a powder coating application where the robot is doing the spray paint job using powdered materials. There are industrial robots, there are collaborative robots, cobots, also known as cobots, so COBOTs. So this is what collaborative robot is, where the human can work with it together without being cut into half. What happens in industrial robot is they're like moving very, very fast. You can see here that this is doing very slow, very peaceful and easy. Even if it hits you, it will just touch you. You won't feel it, and it will probably stop once it is like touches some human being or touches something else. So what it should not touch. So that is what collaborative robots are. They are safer to work with human beings, and they're also in a sense slower compared to the industrial robots. If you are going and seeing an industrial robot, it's probably inside a cage, because they know that if you are going inside the cage with the industrial robot, you will be cut into half. You will be in pieces probably. This won't do that. This is very slow, and you can see it's pretty safe to work around or walk around this. The features for this particular robot that Orangewood Lab has done R&D for years and years and have achieved it is like it has a payload of 5 kilograms. So it can lift a material or article or object or anything that can be weighing up to 5 kilograms. That's quite a lot for this particular robot. And there are different type of degrees of freedom you'll hear with the robots. Degree of freedom basically means how many motors are connected to it and how many motions the robot does. Here, degree of freedom of this particular robot is 6 degree of freedom. We have 6 motors attached to this robot, and I'll show you in the video right here. Let me just change the camera. And also we have something called as teleoperation, where teleoperation basically means you're operating something wirelessly or away. The cool part about this robot is you can be sitting in US, you can be sitting in Dubai, Oman, Australia, Antarctica, or Africa, it doesn't matter. You have internet connection, you have access to the robot, you can control the robot from any place in the world. This is a general UI for this particular robot. You see the screen that is shared is showing the user interface, and I can click any particular part and I can move the robot. As you see, the robot is moving, and I can move some other part of the robot as well. As you can see, the robot is moving pretty slowly. Okay, I'll just change the camera angle because it's slightly bad.
Shanky, maybe you could just like when you share, right? The screen is the screen is actually showing instead of the camera one that shows the robot in your place. So it would be great if you could stop sharing and then show, and then you could maybe simultaneously do that.
Okay, I'll just do this then.
Okay.
Yeah. So this is a robot, and the bottom one, it's difficult to see. So there's base where the motor is. Then there is shoulder, which is the first motor that is connected to it. Then there is elbow, just like our arm, just like a hand. I'll be moving in front of the robot so I can show you this better. So we have the base motor at the, and then we have the shoulder, just like a shoulder. So base is the rotating like our arm. The shoulder is this shoulder where you can lift things up. So this is doing, the shoulder is doing the heavy lifting here. So this whole is the shoulder arm. This is the elbow, just like our elbow. One sec. So this is the wrist, which is rotating around. This is another wrist, and this is another wrist. So here at the top is what basically you put the end effector or the arm that you want to put it. If you wanted to lift a coffee cup, if you wanted to lift a phone, if you wanted to punch someone, you can put a boxing glove on top of it. If you want it to poke someone, you can just put a pencil. So spray paint, put a spray paint on top of it. You can do different things with this. That's the whole idea of this collaborator. As you can see, it's slightly taller than me. It's not very big, and it only weighs around like 26, 28 kilograms. So that's pretty lightweight, approximately the weight of 14, 15-year-old human being. Because it's lightweight, it also moves pretty slow. Okay, a lot of things that are happening in the office. So this is the whole idea behind this robot. And because we have teleoperation, you can get access and control this robot from anywhere. If you want to change the code, you can change the code. If you want to make it do some new different applications or do new different tasks, you can just change it. So that's the whole collaborative aspect. And that's the best owl bot right here. So
could you like show anything that the robot can do now, if possible?
Yeah, I need to control it from the behind the scenes basically. So let me just change this.
Okay.
Yeah, so this is the demonstration that we can give now because the robot is being occupied again. So this is the AGV that we have, the four-wheeled robot with the case and the cool aspect with the arm that's mounted on top of it. This is my friend and colleague, Du, who will be operating the robot.
So Dhruv, let's make it do something cool. So that is also being occupied as of now. And we are back to the controls of this. This is what happens in a busy office. So we have this robot and the UI, which you can move it. As you can see, the robot is moving. I'll move another joint. You can move another joint. You can move another joint. Another. And another. The last one is difficult to see because it's rotating on its own. So just mount the camera so you can see it better.
Shanky, you said it has 6 degrees of freedom, right? Because you
Yes.
said 6 motors are used. Could you just show those areas that will?
Yeah. So back here. So this is the base. The base will basically rotate around. So that's the first degree of freedom. Then this motor becomes the second motor, the shoulder, which will literally lift the arm. So shoulder is doing the heavy lifting of the whole robot. So that's become the second. The third is right here, which is the elbow, just like an elbow joint. So this is doing the heavy lifting of the upper part. Then there is wrist one, which is here, which is rotating like this. So this arm will rotate. Then there is wrist two, which is right here, which will be able to lift and move this particular system around. And then there is wrist three, which is rotating the whole end effector that we can attach on top of it. So if you're holding something and you need it to rotate, it will be doing this particular task right here. So this is like
That
one,
is the portion
two,
you said we could customize,
four,
right? The
5, 6.
top part.
Exactly. Yes. Yes. That's exactly right. So that's the
So
whole
could you show
idea behind it.
something if possible? You have shown in video, I think, right?
Yeah, I've shown in video, and I can share some screen and show some more videos. Yeah. So we are right here. We have shown, I think pretty much we have shown all the examples that's possible. Here is one of the example of welding operation. So the robot does welding work. Anything that you put at the end of it and you program it to do its work, it will start doing the work. If you wanted to do welding, if you wanted to do dancing, if you wanted to do singing, probably you need to add speakers, but yeah, singing doesn't make sense for this. You can tell that to Alexa. So here you can see that it's doing the welding task and it's pretty bright. And as you can see, it's wearing a cloth. So that is to prevent anything or any particle that can go inside the robot or can create problem for the robot itself. So it's wearing a protective jacket. It's called a jacket. And as you can see, it's doing the welding task in a factory environment. Right now, several of our robots are deployed in a factory environment for collecting a lot of data that we can get. And this soon will be launched in the market, and hopefully we are aiming to see our robots everywhere in the world.
Yeah, so maybe I could just share the screen and show your website as well. I've kept it in Chrome. I'll just show.
Sure, that would be great.
I've just touched.
I'll just stop my share. Yeah.
Just a minute.
If you have any questions, you can just let me know. You can just even text me right here.
So yeah, here is the website. You can go check orangewood.co.
Is it visible?
Yes.
Okay, so this is the website of Orangewood Labs. Here you can see their robotic arm, which he was demonstrating. So these were the videos you were showing, right?
Yes.
They're on the website. Yes. Yeah, so here you can see how this top portion could be attached, could be customized to do a lot of tasks. So he showed welding, and then we also saw some, I think there was suction pull, right? Where you could take
the lifting up thing was suction, and here it's doing, we have added a paint gun, so it's doing the spray painting. And
so,
there have been
as you said
times
in the
when we have
something
added
that's interesting is the yeah, something that's interesting is the story behind Orangewood. You might have all heard how it was like a furniture company in the beginning, and now it's like a robotics company, which is so cool. And what they have said, the reason why they have started it is because you said it was because paints has toxic and it is difficult for people to do that task. And so here you can see how they have you could see here how they have attached that top portion to, I think, some painting spray or something, so that without any issue, I mean, without any hassle for any human beings, we could control it from different places as well, right? Which is really nice.
Correct.
So this is the website, and yeah, this is the suction one. This is the painting one, right?
Yes.
Yes.
If you scroll below, you can see different specifications of the robot itself that I have explained. The 6 degree of freedom, the safety sensors that's there. Just go slightly more below.
Yeah, here it is given. Their motto, I think, democratizing manufacturing one bot at a time.
Bot at a time, yes.
So you're taking orders as well, right, for this product?
Yes.
But you said you didn't.
They're definitely taking orders right now.
So it'd be really helpful for people. I think, as you said, it has 6 degrees of freedom, and the top portion can be used for a lot of things.
Yes.
So it could be used in a lot of industries today. Yes. It's pretty cool.
You can go more below, and we have given the specifications as well. If you go below in the product section.
And we also have
slightly more below.
This section, right?
Yeah.
You could just read what's being shown. For me, it's actually blocked here because the screen is. You could actually read what's.
Yeah, sure, no problem. Sub-millimeter repeatability means that the robot can go to one particular point, go somewhere else, do something else, come back here, and that would only have a deviation of a very minute millimeter. It's approximately 0.2 mm. It's like as thin as our hair. So that is how it can come to the same position, same location, again and again without deviating from the goal. And 5 kilogram payload basically means how much it can lift. So do you lift Pro? It does lift 5 kilograms. So 6 degree of freedom is basically like I showed you, like the 6 motors that's there. And the reach is 860 millimeter reach, which is approximately 80 centimeter, slightly less than a meter. So that's the height of the robot where it can go around, reach, lift something and come and do something else. That's the whole area that it can cover. Teleprogramming is basically what it means that I can control the robot anywhere from the world just with the power of internet. So this is technically an IoT device as well. Smart safety sensors is like if I go or walk around the robot, it will either slow down, or if I touch the robot, it will stop. So it is pretty safe to work around or be around, and I can literally push the robot. Okay, go out of my way. I need to do my work. So sometimes we do that. Like, okay, robot is doing its work, but it's also in between our work. So we just push the robot around. It just goes away like a shy person, and then we do our work, and then it comes back and sees like, okay, nothing is around. Okay, it start doing its work again. So that's what the whole idea of safety sensors basically. And it's not very powerful. It is powerful, but because of the safety systems built up in it, it will not literally be very, very fast moving around people, and it will do its work pretty slowly and will do it very diligently. So that's the whole idea behind this.
Yeah.
I'm for a Q&A
so we
now.
have come to know about almost all features and functions of our boat. And then what else do we have in the website? I think we have more. Yeah, you could also contact them, right?
Yes.
For a demo.
Yeah, for a demo, you can contact for a demo. If you also looking for a job or internship, you can apply to our career section. There's sort of availability for electronics, for computer science, and different sections altogether. We have Facebook, Instagram, LinkedIn, Twitter. You can follow all our social media and see what we are doing. There's very fun things that we do in our office. There's a lot of fun videos that I've posted online. So you can go check that out as well.
Yeah, you could check out Shanky's Instagram account. You could share the link if possible here so that anyone who's interested.
I'll just share my Insta tag so you can check it out.
Yeah. Could share your usernames.
Yeah. Yeah, you can check like Shanky_robot. That's my Instagram profile. And for Orangewood Labs, let me just type it out. You can just type Orangewood at the rate Orangewood Labs. So you'll be able to check the company's social media as well. Yeah, right here.
So we have covered almost everything, I guess. Anything else you would like to show there, demonstrate there?
So this is all good for the start. I'm open for a Q&A. If anyone has any questions, I'll gladly and happily be able to answer. So any questions, guys or girls?
Yeah, anything else you would like to ask more about our board or what are its functions? And maybe you could talk about the technology you have said me that it was using ROS, right? So maybe you could talk a little bit about that.
Yeah, that is one of the most important things. What people or the world is moving towards is open source technology or collaborative working. So we are using ROS, robot operating system, which is an open source software, a middleware to control any robots. And all our robots in our office that's there is working on ROS. And many other companies, MNCs are working and moving towards using ROS as their main middleware to control the robot, work with robot. So people can collaborate with them. They can create their own functions, own programs. And because it's a very beautiful, versatile software, you can do any applications with it. Like literally, there are several applications that the company did not even think of, and people have developed that program and put it on GitHub, GitLab, different other open source platforms, repositories, so that you can just try it out. And if it does work for you, you can just use it for free without paying anyone anything. It's just like a good thing that you're doing to the world, where technology is growing and growing because people are coming together and contributing towards it.
Yeah, that's great. And I think ROS something is definitely any one of us can learn online as well. I've seen there are a lot of courses for that, which is crazy,
Yes.
which is amazing. So that is about the technology, right? That you're using ROS like many companies. And anything else you would like to share? I don't know whether you have any questions because we have less participation, but I'm sure that many will be seeing us online on YouTube. So you could contact him. So at the rate Shanky and _robot, you could send a message to him via Instagram, or you could also follow Orangewood Labs on Instagram, and you could ask them. You're also there on LinkedIn, right?
Yes.
Orangewood Labs and your personal account. You're there.
Yes.
In almost all social media accounts, right? So it's great. So you could contact him, and I've shown their website as well. So you could contact them for a demo as well. So thank you so much for joining us. And if you guys have any questions, please do post it in the chat box. Otherwise, we could wind up. So
hello.
The robot is moving around. That's what I wanted to show.
Hello, am I audible?
just a minute. Let me add spotlight.
Hello. Aisha, am I audible?
Yeah.
That is the other robot you were talking about that's being attached, right?
That's a robotic arm, and this is our AGV. So, I okay, I should move away. So yeah, that's it. Thank you so much for inviting me for this particular session.
Thank you so much for joining our first session. We are so happy to have you, and maybe we can have you. We'll surely have you in future as well. And thank you so much. And as I said, if you have any doubts, you could ask him through his Insta. You could contact him through his Insta account, or you could contact them through their website as well. And it's also a product that they're selling. So if any of you really want to know more about it, you could contact them, and they would definitely let you know further about its features and which all industries can use them and all, right? So thank you so much everyone for joining. I'll just end the YouTube live. Thank you, Shanky. Thanks a lot.
Thank you, Aisha. Thank you, Robovice, and all the team that is working behind it.